I am Vanessa Madarjith. The title of my project is to investigate the antimicrobial effect of clove extract and eugenol standard on Escherichia coli, Bacillus subtilis, L. caligenus faecalis, and Streptococcus mutans. The emergence and spread of drug-resistant pathogens that have acquired new resistant mechanisms leading to antimicrobial resistance continues to threaten our ability to treat common infections. The rapid global spread of multi- and pan-resistant bacteria, known as superbugs, cause infections that are untreatable with existing microbial is quite alarming. Hence, more efficient alternatives are required. Eugenol is commonly obtained from the natural essential oils of plants from the Lamiaceae family and is the most important component of cloves. Although it is known to occur in various concentrations depending on the species, the richest source is cloves. Eugenol has been scientifically proven to be pharmacologically active against gram-negative and positive bacteria. Apart from its pharmacological activities, eugenol is also used in food preservation. The primary objective of this study was to extract eugenol from clove buds and leaves, and the secondary objective was to investigate the antimicrobial effect of clove extract and eugenol standard on Escherichia coli, Bacillus subtilis, L. caligenus faecalis, and Streptococcus mutans. It was hypothesized that clove extract and eugenol standard has antimicrobial effects on E. coli, B. subtilis, A. faecalis, and S. mutans. Eugenol was extracted from cloves via surface extraction and concentrated using rotovaporization. Headspace gas chromatography was conducted to identify eugenol. This diffusion assay was performed to assess the antimicrobial effect of clove extract on E. coli, B. subtilis, A. faecalis, and S. mutans by measuring the zones of inhibition. The minimum inhibition concentration assay was conducted to determine the lowest concentration of clove extract that inhibits microbial activity of the bacteria. This diffusion and MIC assay was also conducted on the eugenol standard. Statistical analysis was performed using one-way ANOVA, and data was expressed as mean SEM. In the disk diffusion assay, clove extract had statistically significant antimicrobial activity only in the following doses: 120, 150, and 200 micrograms per mol in E. coli, 30, 60, and 90 micrograms per mol in B. subtilis, 90, 120, and 150 and 200 micrograms per mol in S. mutans, which may be clinically beneficial as an antibiotic and had statistically insignificant antimicrobial activity in A. faecalis, probably indicating higher doses may be required or it necessitates a synergism with other antimicrobials to observe clinical significance. In the MIC assay, both E. coli and B. subtilis exhibited a high MIC of 500 micrograms per mol, indicating that they are less susceptible to the clove extract, suggesting that clinically a larger dose is required to suppress their growth. A. faecalis showed an intermediate MIC of 250 micrograms per mol, suggesting it is more sensitive than E. coli and B. subtilis, but less susceptible than S. mutans, which had a low MIC of 62.5 micrograms per mol, which has clinical relevance where a lesser dose is sufficient for therapeutic or preventative intervention. Thus, antimicrobial activity of the clove extract is highly dependent on both the concentration and the specific microorganism, elucidating that its efficacy is mediated by strain-dependent interactions related to differences in cellular structure and metabolic responses. In contrast, in the disk diffusion and MIC assays, the antimicrobial activity of the eugenol standard was invalidated due to the inhibition of antimicrobial activity in the ampicillin-treated groups. Future research could entail exploring combination therapies and investigating pharmacokinetic and toxicological profiles that can bridge the gap between promising in vitro data and effective clinical applications, thereby contributing to the global challenge of antimicrobial resistance. Further optimization of the methods required to reduce variability and a wider range of doses, plus more outcome measures, may provide further insight to its antimicrobial activity and potential therapeutic value. Also, a more robust study could be conducted to include a greater spectrum of gram-negative and positive bacteria.